Welcome to question 20 from the 2020 TMUA, paper 1. The question asks us, for how many values of a does the equation x minus a times by x squared minus x plus a equals 0 have exactly two distinct solutions for x? And our options are 0 values, 1 value, 2 values, 3 values, 4 values, or more than 4 values. Pause the video here and have a go at answering this question for yourself. Okay, well, if we look at the left-hand side, we can see that the solutions for x will be x equals a, because that makes this bracket equal to 0, and also the solutions to the quadratic equation x squared minus x plus a equals 0. So in order for there to be exactly two distinct solutions for x, two of these three solutions need to be the same. So a is already one of the solutions, so if the quadratic x squared minus x plus a has a root which is different from a and is repeated, then we will have the solutions be x equals a and x equals this other root and no other solutions, so we would have exactly two distinct solutions. And also, if a is one of the roots of this quadratic x squared minus x plus a, and the other root is distinct from a, then our two solutions will just be a and this other root, because a will be the repeated root in that case. So we can write this down. To recap, our two possibilities are firstly that this quadratic x squared minus x plus a has a repeated root which is not equal to a, and our other possibility is that a is a root of this quadratic x squared minus x plus a, but it's not repeated, because if it was repeated then there would only be one solution to this equation for x, and that solution would just be x equals a, so there needs to be some other distinct root. Okay, so now let's have a look at case 1. So if x squared minus x plus a has a repeated root, what does that mean? Well, that means that it can be factorised as x minus b squared for some number b, but we need to have b not equal to a, because b is going to be the repeated root of this equation. Okay, so what can we do now? Well, we can expand out this bracket, x minus b squared, and that's equal to x squared minus 2bx plus b squared. And we need this to be exactly the same expression as x squared minus x plus a. And therefore, we can just compare the coefficients and see that tells us that 2b must equal 1 and b squared must equal a. Okay, well, looking at this, 2b equals 1, that tells us that b must equal a half, and a equals b squared, so therefore a is a quarter. So case 1 can only happen if a equals a quarter. Okay, now let's look at case 2. We want a to be an unrepeated root of x squared minus x plus a. So what does it mean if a is a root of this expression? Well, it means if we plug in x equals a to this expression, then it will equal to 0. So what we're saying in case 2 is that a squared minus a plus a equals 0. Now minus a and plus a just cancel out. So case 2 only happens if a squared equals 0, and the only time that happens is if a equals 0. However, we need to check that this gives us an unrepeated root, otherwise we might have the case where a is the only solution to the overall equation. So indeed, if a equals 0, then x squared minus x plus a is equal to x squared minus x, which factorises as x times x minus 1. So the roots of this equation are 0 and 1, so indeed 0 is an unrepeated root. So therefore we can see that case 1 and 2 are both possible. Case 1 is possible if a equals a quarter, and case 2 is possible if a equals 0, because it gives us a root which is not repeated. So our solutions are a equals a quarter or 0, and therefore that means that there are two possible values of a, which was option C, so our answer is C.